Afternoon. This is Ian Gonzalez, and joining me once again would be my brother Lucas.
Hello.
And today we're going to discuss the jumping spider. Specifically, we're going to be looking at the vision of the jumping spider, or a study that will be conducted. The study has not been conducted yet, but they're producing plans for studying the spider.
What will be the two spiders for the study?
Well, they plan to use the Phidippus audax and the Portia spiders for the study. And first, I'm going to provide a little background concerning both of these spiders. First would be the Phidippus audax, I believe it's pronounced. This is known as a common jumping spider in North America. It's also referred to as the daring jumping spider or the bold jumping spider. They're mostly located around southeastern Canada and most of the United States. What's concerning the living locations of these spiders, they don't build webs to catch their food. Rather, they hunt for their prey. They actively hunt for their prey using their jumping techniques. The only case where they build webs is used for housing eggs. Now, this spider is rather small. It's anywhere from 13 to 20 millimeters in length. In appearance, they're usually black. Their carapace is black with stripes all across their body or spots. They're particularly known for their ability to jump great distances. They do this by increasing their blood pressure in their front two pairs of legs, allowing them to go about approximately 50 times their own body length. Now, the other spider in the study, which is the Portia, is also dark black, and it has sort of light stripes. It looks very similar. But this spider lives in near Africa, Australia, and Eastern Asia. But their hunting strategies vary from that of the Phidippus. Its main prey would be the web building spiders. They're usually considered very interesting, as this particular spider outsmarts its prey and seems to observe and analyze how its prey works. It learns different tactics for different situations. And can often take on prey that's much larger than itself. When hunting other web building spiders, it tends to press its limbs on one of the threads and move in a sporadic motion, sort of simulating an insect caught in its web, drawing out its prey to see if it caught anything. But at that point, the Portia spider then kind of retracts, stalks its prey, and then attacks it from a different angle. So the prey is completely unaware of its existence until it drops down using a web and eats it. Now, the pitfall of this spider, even though it's considered intelligent or adaptable, or it can it's adaptable to different situations. Because of its small brain, it's very slow thinking. It has a slow processing speed. So naturally, it moves slower than its cousin, the Phidippus. But it is still amazing nonetheless. But of particular interest of the study would be its eyes. These jumping spiders are distinguishable not just for their jumping habits, but because of the placement of their eyes, which allow what's called stereoscopic vision.
Why is stereoscopic vision important?
Well, stereoscopic vision is important because it the spider needs to be able to identify its prey, be able to judge jumping distances, be able to track movement. And for this, they have 8 eyes located around their head. They have 3 pairs of that are, like I said before, used for tracking movement, and then they have a pair of forward-facing eyes called the principal eyes, which sit in a sort of constructed eye tube which are densely packed with photoreceptors and give very powerful vision. But the pitfall of these forward-facing eyes is that their range is very narrow. So they have muscles that can adjust these eyes so that they can track movement, and that's of interest in this study. Now, in the article of interest today, an individual named a researcher named Elizabeth Jacob of the University of Massachusetts Amherst plans to create an experiment. They just got a grant for this new motion tracking machine, which is used to track the principal pair of eyes on the spider. This research is important because it allows the researchers to see what attracts the attention of the spiders, how they distinguish between prey and mates, and so on. So how they plan to conduct this experiment is they place the spider on a cork and hold it down with wire. Then they have the instrument in front tracking the eye movements of the principal eyes, and then they take readings on this eye movement using an infrared sensor, which pinpoints the retinal focus of the eye. They use the retinal sensor the infrared sensor on their retina because they can't see this wavelength of light. And then after that point, they'll be exposed to a screen showing them different images that might attract their attention.
Will they react to a screen?
They have done tests in the past. They've actually shown that the jumping spider will actually attack a computer screen showing its prey, such as a grasshopper. So they know that this will work. They just want to study the muscle movement of the eyes, and there are plans for future research concerning this in this field, but now looking at the secondary eyes. But as of now, their plans are for the principal pair of eyes. So now I'm going to open it up to discussion with my friend here, Lucas. Looking at how the spider eyes track, like, how do you think that they can distinguish between a mate and their predator, their prey? I mean, do you think there's a specific shape or arrangement or color, because they have a very strong sense of vision?
Okay, well, if they have a strong sense of vision, I believe they'd be able to tell a spider of their own species. However, distinguishing whether it's friend or foe, I'm not entirely sure. Maybe the way it reacts around the other spider, I can't say for sure.
I did actually read some interesting bits. That's a good point. That they have a certain communication where it's not so much a dance, but it's a sort of movement that these spiders make, and that might allow them to distinguish each other from each other, as opposed to what they may consider harmful or as potential food for them. What do you think that with the future experiments? What do you think that the secondary eyes, the ones that show movement, what do you think that they'll probably do for the purpose of studying that?
Like, how will they? Wait, can you rephrase the question?
Oh, sure. How will they test the spider's ability to track movement using these secondary eyes, as opposed to looking at the forward eyes, which are used to focus on certain areas for actually analyzing and taking in optical information?
I would guess that they would not. Maybe they would. I wouldn't say blindfold the primary eyes, because I don't know how that would actually work out on the creature. Maybe they would just sort of cover it up or something, and then they would show movement, like on a TV screen, to see how the eyes react when a ton of movement is shown, like in sporadic movements. Okay.
I agree with you. I think that makes a lot of sense. But at any rate, thank you for joining me today, Lucas.
Yeah, man.
And I'll talk to you all later. Thank you.